Good morning, everyone. Thank you for joining us for day 3. I am Nikita. I've been around since Monday, but I didn't formally introduce myself. So I am Nikita. I am a postdoc in nuclear physics at UWC. I moved to Cape Town in 2019, just a few months before the world changed forever. So I got a small taste of Cape Town before that. And I'm originally from Quebec, the French province of Canada, if you are wondering what kind of accent that is. So in my work, I use a lot of Linux, especially Ubuntu, which I will use today. And we will focus today's whole session on Git and GitHub with automated version control. So that is the goal of what we're doing. And we can start with the nice comics there that we have on the course website. So I'm sure we've all been there when we think we have a final document and then we have somebody, a supervisor, a prof, a teacher, giving us edits, and then we have revisions, and then more revisions, and then more revisions. And it just becomes a giant mess. We try to keep different versions to keep track of our edits, but it is a nightmare if we want to go back to something that we've done before. So this is where automated version control comes in to help us. And we will do this using Git. So this is a diagram of what is happening. We have an original document, and it knows what the edit we did. It keeps track of how it merges with the original version, and it keeps track of further edits, how they merge with the edited version. So it keeps track of all the changes that we do, so we can always go back to them. For example, when we do codes, maybe one day a code is working and then you keep working on it and it doesn't work anymore. We don't have to panic because we know we can always go back to see how it worked before. So we have different situations. Here we have 2 people collaborating on the same document. So this can be very time consuming if we wait for one person to do the changes at a time, do the edits at a time before they can give the edited version to the next person. Instead, we can both do edits at the same time, and the automated version control will keep track of the edits individually and see how they can merge them together. So here we have the other way around. We have the edits merging together. And this is it for the purpose of today, the automated version control. So we use Git, and the interface that we use to interact with Git today will be GitHub on the web and Git in your shell. So here we are going to start with setting up Git. First, I would just like to make sure everybody has Git. So if you go to your shell, I will go to mine here. Share, so you should see my Ubuntu shell right now. So Verena was working in the Windows shell directly. We also have people working on Mac, people working on Linux. And in my case, I'm working on Linux Ubuntu, but on Windows. So those instructions were not directly given on the Carpentry's website. So this is my own personal opinion. This is the Ubuntu subsystem for Windows. So it is totally integrated in Windows. It's not like a virtual machine. We don't have to reserve resources for this. And it works just like a Linux machine. So you won't see any difference today, but just so you know, I'm still working on Windows, but I have this genuine Ubuntu shell. So here, if everybody has their shell open, you can just do Git, enter, and see if it complains. So in my case, is giving me all the tips on how I can use Git, so I know it's working. Can everybody please confirm that you have Git working? Maybe with a thumbs up or the chat, just so we're all starting with a working Git. Will I be able to see the thumbs up?
I can communicate them, Nikita. So we had
thanks.
Almost everybody give a thumbs up. So I think
perfect. I missed that. Okay, perfect. Thank you for that. So we're all on the same page. I'm just quickly going to clear this because it's already a lot of info. And now Git has a lot of settings. So we're going to start with I'm going to show you what I have with git config hyphen list, enter. And this shows all the default settings or the settings that I set for my own Git. So I already set up my name, my email, my favorite editor, and the file mode here, what it recognizes at the end of a line. So now we are going to set yours as well. So let's start by setting your name. Git config global user.name, and then between quotes, write the name that you would like to have attached to all the edits and the comments that you do to the codes that you keep track of in Git config. So I'm actually going to change my name here from Nikita Burn to just Nikita B. Oops, I can see I already made a typo. This was username. And then I do enter. Nothing shows up. He accepted it. Once you set up your name, you can set up your git config global user.email. So here you can write any email you like. If you want your email to stay private, when you made your GitHub account, you had a username. So mine is Nikita Burn. So you can use your username with the end of the email, users no reply github.com. So I should have asked also, did you all get a username from GitHub? If you did, you can just use it to use the secret email address, so it will hide your own email address. And GitHub will handle sending the messages to your account. Please slow down a bit, okay? So yeah, did I get answers for getting the usernames for GitHub? Does everybody have a GitHub username? I get 1 thumbs up. 2 thumbs up. Not yet. Okay, so we will have to go back then. First, so if you have Git working, quickly making an account outline. Okay, good, perfect. So thank you for letting me know. So now let's circle back to GitHub. In order to set up our settings, we will need a GitHub account already there. Let me share my GitHub. So here, this is on the GitHub website. This is my page with my username. So you should all have an account created so we can set up the settings of your Git on your shell. So if you can let me know if anybody does not have an account, we will wait for you to do it right now. Okay, so we have Sane who's making an account. Is there anybody else who needs to create an account?
So I've made an email and a password. What do I make my username? What do you suggest? Just like
Yes, whatever you like. Sane should be good if it's available.
okay, I see.
It doesn't have to be your name, so whatever you're comfortable with the world seeing.
Oh, I have to solve a puzzle to verify I'm human.
Yes, that the GitHub is serious about working with humans, so you'll also need an email verification and things like that.
Okay, almost done. Sorry for this. I saw I had to install Git. I was like, oh, I have Git installed, and then I didn't, make sure I actually can go online.
That's fine. We have a few minutes to set everything up. Is it right? Everybody else has an account? Everybody else is ready? Thank you, Yandile, for your thumbs up. I will go back to my shell here. And yeah, I'm just waiting to click enter to submit my username.
Okay, so I think I'm ready. It's just asking me some questions about what kind of work I do. That's fine. But I have a user account now, so can I ignore the like, what features are you interested in? Can I ignore that for now and just go back to my terminal?
Yeah, I'm sure he won't mind, or I hope he won't mind.
Okay, so then I can make my user email, my username as you have it there.
Yes, exactly. Try that and see if he's okay with that. Yes.
Thank you.
For email, do we use the one we created the account with? You can use any email that you like. It will show up. It will be attached with your username with all the edits and the comments that you do. So if you would like your private email to stay private, GitHub gives you the opportunity to hide your email and just using the user's no reply GitHub. But if you want to use your full email, that is totally fine as well. Did that answer your question, Yandile? Perfect, thank you. Okay, so are we back on track? Did everybody set their username and their user email? Sane is all set, perfect. Okay, so I pressed enter. So now I set my, chat, yes, thank you. Okay, now we can go back. We have our username, our user email. What next should we do? Depending on your platform, you will have to choose the right git config global core auto crlf. If you are on Macs or on Linux, like I am right now, I will leave it to input. If you are on Windows, instead of input, you will need to write false. Did everybody on Windows get that? You should use the false if you're on Windows, which I'm not. So if you are on Macs and on Mac or Ubuntu or Linux, you have to do like me and write input. So this will be a little bit different depending on the operating system that you're using. For me, I will leave it to input. Everybody who's on Windows, you should write false. No complaints for anyone, so we can keep going. So we have set up 3 things so far. Next, we have our editor. That will be the last setting that we need to do for today. So for our setting, it's the similar command line. So we have git, we use the verb config. We are still in the global settings, and we always use nano, or so far we've used nano. So let's keep with it. We need to write nano minus W within quotes. Yes. So here we can all keep working on nano since that's been working for the last 2 days. So I will, it does not contain a section. Okay. So my shell didn't like the minus W, so I will just write nano instead. And it does not like that either. So never mind. I will keep my gedit because, oh no, I'm missing.
Problem maybe that, yeah, core.editor.
Exactly. Thank you. I am missing the core editor. And then this should work. So I need to tell him what setting of global I want to do. Core editor, nano minus W within quotes, and then he did not complain. Perfect. Okay, so those are the 4 settings we need. We have a username, an email, we have the character for the end of the line in our own operating system, and we are still using our nano by default. We can check again our git config list just to check that all the changes you did worked. So here my username was changed from what it was before. My core editor is now nano. So just run this and check that the edits that you did were accepted properly. Did that work for everybody? Let me check if I have, yes, I have a couple thumbs up. Thank you. Just in case we have different versions of Git, let's do a final change. We have git config chat. Are the edits saved permanently? Yes, you only have to do this once. So we're doing it together, so you never have to worry about it again, but you can change them again. Just like I did, you overwrite what was written before. So you can update the settings whenever you like. The last thing I want to do is just check the default branch. So we are still git config global in it. Default branch, just make sure that it is set to main. So mine was already set up to main. Depending on the version of Git, it might have a different name. So let's make sure we're all using the same name. Then I want to check a final time config list. Let me learn how to type quickly. Config list, and here we have everything. And that was it. Our Git is now set, and we have all the same settings, so we are ready to go. We've all made it this far. We can move on. No complaints. Okay.
Please.
Yes.
Yeah, when I git config list, I don't get all so much numbers as you. So I don't know. I've got only few lines so far. I can see my username,
Yes.
the email, auto control input, and then the nano editor.
Perfect. Do you also have the default branch?
No, can't see.
Okay, can you do the last command I just did? Git config global init default branch and call it main. Everything else is coming from work that I already have. So don't worry about the other settings.
Default branch main.
Yeah, we're going to assume we all use the main branch. The name of the main branch will be main. So we need to make sure we're all on the same page.
Okay, I did that.
You have this?
I just did it now, so I will list again. Yeah, I can see default now, main.
Beautiful, perfect. So we know we're all on the same page and we won't get lost later when we start working. Thank you for making sure you're on track. So after we set up Git, I will show you the very nice picture we have on the website. So we have, like for the Unix lesson we had, where is it? Here. We had the story of Nelly, who was doing her work, her thesis. So today we have something a little bit more exciting than doing research in a thesis. We are working with some interesting people. Dracula, Wolfman, and Mummy are looking into the possibility to send a planetary lander to Mars or to another planet. Maybe we should investigate other planet. So I'm just giving you the setting for all the lesson here, the little characters that we will be dealing with are very funny people. So we are now looking into creating our first repository. So we have our characters, and I will go back to my shell so we can create our first Git repository together. So here I have my Ubuntu again. Let me clear this. And we will work from our desktop like we did before. So I'm going to change my directory, go to my desktop, enter. So far, I have nothing. I removed the shell lesson. Sorry, Verena, I needed space. And we're going to create our planet directory because today we are investigating planet. So I'm going to make a directory called planets, enter, and I'm going to change directory, go within my planets directory. ls, there is nothing in there. It is a brand new directory. And this is the directory where I want to get to keep track of the edits that I'm doing. So we call that a repository, a place where Git stores the different versions of our files. In order to tell Git to keep track of this, we tell it git init to initialize it. And we say enter, and that is it. Git has the initialized empty repository in this place right here in the planets directory. So if we do ls, there is still nothing. It is still an empty directory, but let's use the flag ls-a to show everything that is in there, including the hidden files. And now we see that there's something new. We saw earlier this week that we always have our dot, that means the current directory. We have the double dot, which is a level up, and Git just created a hidden file called .git. So this is the hidden subdirectory where Git keeps all the versions of our files. This is where all the magic happens, so we don't want to delete that. If you change your mind and you do not want to keep track, this is where you go to delete it. But this is not what we want to do right now. So we've just created our first repository, and we know where it keeps all the different versions of our work. So next, we want to check the main. So we already called the main branch main, and we want to use that default branch, sorry. So to do that, we use git checkout. Checkout means using the version we're going to give it next. So to do that, we do -b and the name of the branch. In our case, it is main because we said it should be main. Delay, if you don't have the .git, that is not fine. It means you did not initialize your directory. So if you go back, did you do the git init in your planets directory? I was not watching for the thumbs up. Did you give us a thumbs up? Did you find your .git? I see you missed that. Perfect. So once you do your git init, it tells you that it did initialize the repository. So you should have that. But it's definitely good to check. Okay, so now that we know it is initialized, we want to make sure we are using the branch that is called main. So I'm going to do enter, and it tells us that it switched to the branch called main. So far, so good. Everything is working as it should. And at any time, we can check the status of our work by doing simply git status. Enter. It tells us where we are. We are on the main branch. There are no commits yet. We haven't committed any changes to our work. And there is nothing to commit because everything is empty. We haven't created or copied file. And here we have a very interesting foreshadowing. It warns us that to do commits, we will have to use git add. So the comments that we receive in the shell are usually quite helpful. So here, let's keep going. Just to do a quick example. So we are in Planet. We have one person who's interested in planets, and let's say somebody else wants to look into moons. So within, let's check where we are. Here I am in planets, and within planets, I'm going to make a new directory called moons. I'm going to go into my subdirectory moons within planets, and they also want to keep track of git moon. So their first instinct would be to do git init within moons. So now we have an initialized git repository in planets, and within planets we have moons, which is also an initialized repository in Git. However, Git is very nice and very logical. So when we initiated the planets repository, it automatically keeps track of all the files within it. So what I did just here to initialize a sub repository within planets is not good practice. So this is not a good example. I'm doing this to show you how to undo this. So like I said earlier, the ls-a in the .git is where all the magic happens. And here we have a redundant repository because all the changes in moons are already taken care of in planets. So in order to remove this, I'm simply going to remove that directory. So I can do remove. Well, first, we always need to make sure we are in the right directory. We don't want to delete the .git for planets. So here I am definitely in moons. And I want to remove the moon. We are already here, the .git. I'm going to do that and see what happens. Do you remember this mistake? When the terminal tells us that it cannot do something because there's no such file or directory. So here, well, first I put the slash. Never mind, let's try again. So here it tells you is a directory. Do you remember what we need to do in general when we want to do something in a directory? I realize I'm asking a very confusing question, but I want to know which letter I'm supposed to add here. Exactly, Sade, thank you very much. We want to remove -r, our Git's repository, our Git directory. So here I'm just highlighting that this is not one file. This is a hidden directory where all the versions of our file are clear. We don't even need to go this far. Just this will remove our .git. Let me check again. It is gone. So now there's no more confusion between the moons directory also being tracked in Git. Everything is already tracked into planets. So this might sound like a small detail, but it can get very confusing. There can be conflicts in the versions that are saved within Git. And if you ever initialize a directory that you didn't mean to, now you know you can just simply remove it and you can forget about it. So now I am in the empty moons directory. I'm going back one directory up in my planets directory, which only has my empty moons directory. So we've completed our second step. Our first step, we set all the settings of Git. Second, we created our first repository. Any questions so far? Everybody's here? Thumbs up. Thank you. So far it was just a couple commands to do housekeeping. Like I said, the settings, you only need to set them once, so you can already forget about this until you want to change them again. And then all the instructions are on the course website, so you know where the information is. Now we start using Git, which is the goal of Git is to track the changes that we do. So we've created a repository, but how do we record the changes that we do in Git? How do we check the status of the version control, all the versions that we have? And how do we record notes about the changes that we make? So we will start by taking notes about our planets. So I'm going to be in my planet directory, like I just did, and we are going to create our first file in our repository. So I'm going to use Nano to create notes about Mars. Mars is the first planet we're interested in. Here I'm going to write my first thoughts about Mars. Mars is cold and dry, but everything is my favorite color. That is it for now. That is my first piece of information about Mars. I'm going to save this with Control-O, Enter, Control-X. I'm going to check that the file was indeed created with ls, and I have mars.txt that was created. I want to check that my edits to the file were created properly, so I'm going to cat mars.txt, enter, and I see that my first line was indeed saved, cold and dry, but everything is my favorite color. Now that we have a file in our tracked directory, planets, I'm going to check the status. You can always check the status of the work, what is tracked and what is not. If you've done edits that are not saved, Git will tell you right here when you asked Git status. Enter. It tells me I'm still on the branched called name. I haven't committed any of the changes. However, there is a file that was created and is not tracked yet. The name is mars.txt. And there is nothing added to commit, but there are files that are present that haven't been tracked yet. And Git still gives us the hint, we haven't used git add yet. So here, before we commit changes that he will put in the .git repository where he saves all the version, we need to tell him what to put there. So we don't have, it doesn't automatically saves everything at random intervals of time. We have to tell it, okay, I'm done with my work for today. I would like you to save that version before I save anything else. So we do this by saying exactly what Git tells us to do. Git add and the name of the file that I want to track, mars.txt. Enter, nothing happens, but let's see what changed. What is our current status now that we added the file to be tracked? We are still on the main branch. There are no commits, but we have added the file to be committed. So here we're saying this file, this new file mars.txt is added to the staging area. We are ready to push that into the tracked file, so we keep that version. So, oops. Hello, here. Okay. Now that we add our file to the staging area, we can actually commit the changes. So this is a new command as well. After we do git add, we do git commit with 2 M's, then with an extra flag with an M, that means message. And then within quotes, we say a message, so a very descriptive message, so that we know what those changes were about. So when we do a bunch of changes, if we have a not descriptive message, it will be a nightmare to ever go back when we want to find that special change that we're looking for. So here we have to be very descriptive. We just start notes on Mars as a base. Mars as a base within quotes. So this is human readable text that Git will remind us whenever we look at the history of the file later. So here git commit -m and our message, enter. And it tells us, okay, the commit that you just did, the edits that you committed, which is what we call a commit, I give it a special string of 7 characters over here. This is the unique ID for this change. And this is what you told me you did in that change. You started nodes on Mars as a base. This is the change that you did. In this commit, you changed one file, one insertion, you added one line in there. And that is it. He's done the commit. Oh, I have, sorry, when I type git status, I get fatal message. Okay, can you try it again? If you say git status. So Ali, are you still?
Yes. When you see the previous, I think 1, 2 input, the second one, the previous second, you type git start pass and you got on branch name, not commit. But myself, I can't get that one. I'm getting further not a git repository or any of the parent directories. So I'm getting the error.
You're getting an error when you just said git status.
Yes.
Like this. Okay. Did
I'm in planet.
In planets. So you are in planets.
Yes.
If you do ls minus -a.
LS
Do you have the
-a.
.git?
Let me see. No, I have mars.txt and moons.
Okay, you don't have .git.
No.
Okay, so before you do any of this, you need to do git init.
Okay,
like
let me
this.
do it.
Within planets.
Yes.
And okay, so now let's try again ls -a. Do you see the .git?
Hold on.
Do you see it?
Yes, it is there now.
Okay, perfect. So now if you do git status, he will know what you're talking about because he is tracking that directory.
Okay, good. Thank you. Now I see it.
Perfect. Thank you.
Good.
There was a hand up. I think Sade, are you all set?
No, it was me, Nikita. I was just trying to draw your attention to Ali's issue.
Okay, perfect. Thank you. Thank you. Okay, and then it's also you in the chat. Perfect. Okay, so coming back, the last thing I looked at was I did my commit. And after that, I wanted to check the git status anyway. So after you do a commit, it's always good practice to see what the status is. And he's telling me after I've done my commit that I am always on the branch main and there is nothing to commit because everything is clean, everything is already saved. Does everybody have this? Created your first commit? First successful commit for everybody? Thumbs up.
Not seeing any thumbs up yet, Nikita. So maybe they just need a minute or two to get to this point.
Yes, perfect. So let us know when you do have your first successful commit.
Nikita, can you scroll up a little bit to where you did your add and commit and stuff?
Yes.
We can have that. There we go. Okay, great. Can I make a suggestion? Since Ali was now a bit wasn't able to do this. I know that he has to do this now. I like to go to the bathroom. Can I run away for a minute?
Yes, please go to the bathroom.
While we wait for this.
Yes, that's the perfect timing. While we wait for all the thumbs up. Okay, yes, so I'm not sure if I lost anyone. Everybody made it to Git add?
So maybe we should ask if you've all been able to follow so far, or would you maybe like Nikita to take a step back and maybe run through what she's just done again? And people are not too responsive right now, so I'm not sure if that's because you are following along or because you might have gotten lost at some point and now you're still lost. So what would you prefer? Could you maybe just type in the chat? Would you like Nikita to backtrack a little bit and just repeat these couple of steps that she's just done? Or would you prefer we move on after this? It's really up to you guys at the end of the day, because if you're getting stuck, you know, it's no point we move forward. And like I said yesterday, we'd rather do less really well than do a lot and everybody's lost at the end of the lesson. So
Definitely.
let us know. Let us know via the chat, or let Nikita know. And you're also welcome to unmute. Let us know what your preference is.
Yes, please interrupt me if I can help you with anything. Still silence.
I'm back from the bathroom.
Thank you very much for letting us know.
Sorry, myself, I'm still typing there. So are we supposed to type everything in the last line?
Where are you? Which line?
Okay, this one, git commit -m.
Yes.
So we type everything.
Yes.
Okay.
So let's just check. You did git add, right?
Yes. Yes.
Okay. So once we added the change, we need to commit them.
So you need to press enter.
Yes, after, so here the full command is git commit -m, which means there's a message coming up.
Okay.
Then starts nodes on Mars as a base.
Oh, then you press enter.
Yes.
Okay, let me do that.
And do you see, does it tell you that worked?
Start note. Okay, yes, I'm getting start note on Mars suspense. One file changed to insertion plus created
Beautiful.
mode. Yeah, okay.
You've just created your first commit.
Okay, good.
So after you created your commit, you should be able to do git status once again, and he should tell you that everything is fine. There's no untracked changes, there's no untracked files, everything is saved. Is everybody there, Sane?
I'm just curious. So the git commit, the message that you add, that's optional, right? You could just say git commit with nothing, but it would, I mean, it's not ideal, I assume, but that is possible, right?
If we write nothing, let's let's backtrack. Can I do this? Okay, and if git, let's try it. For sure, git commit.
Yeah, just like that.
Yeah, if we don't say anything, it tells us, yeah, because I didn't make a change. If
but
you just, sorry, yes?
I assume the message is optional, but it is a very good thing to do, right? To tell yourself what you were doing.
I don't think it is optional, but before I say anything, I want to try that. So here I'm just doing a quick change because I haven't tried it. So let's try this. So I just added a quick line. I'm going to git add the change that I want to do. I'm going to check that he's okay with that. Git commit with no message at all. He assumes that you want a message so long that he will open Nano for you.
Oh, wow. Okay.
So
Okay.
then you can write as much details as you want, and you absolutely need to give it something.
Okay. Interesting. And so you
So-
have to go add every time, even if you've already told, like, you've made a change to Mars, and now you say add and then commit. Like there's 2 steps every time.
Every time. That's 100% correct. It is
Interesting.
called the staging area. So if you are working on different files and you don't want to commit them all at once, you want to save one and maybe one another later, you have the option to do that. Or you can put them all at once.
So you
But
could add 3 of your 5 files, and then you say git commit, here's my message. These are the new files I want to save. Okay, I get it.
exactly.
Cool.
So this is, I'm happy you already caught up with that. That's the add is easy to forget, but he will tell you that there's nothing to commit because you need to add first. I have a hands up, Verena.
Oh, it's just from me. I wondered if I could quickly share an image, if you don't mind, Nikita.
Yeah, I can stop sharing.
So this is on the workshop website as well. So Nikita was talking about, the staging area versus the repository. And I suspect Nikita will be going over this anyway. But I think people might be getting confused about the git add and the git commit. So the way
Okay.
the git works is that you've got this staging area. So when you are writing code and you're coding, oftentimes your final product, or before you get to the final product, you've got modifications to make. You maybe decide, I actually don't want this on the repo. I want to pull it back. Maybe I want to delete it. So then that is what the staging area is for. So you put it here, so it's staged. So essentially, it's ready to go to the repository, but you must formally commit it to the repository. So remember, your repository can be public. It can be private as well, but a lot of the time your repos are public. So you don't want to be pushing code out to that repo and out to the public where other people might also have access to the repo unless you're also confident in what you're pushing. So sometimes you want to use that staging area as almost like I think of it as almost like a buffer, where if you're not sure you want to commit it, you still have time to pull it back and it doesn't cause too many issues. And it's another sort of layer of functionality for people who do a lot of coding, to protect them, but also maybe you don't want to really push things to the repo yet. You still have some files you want to add, changes you want to make before you actually commit all of that to the repo. So once you commit to the repo, it becomes also different when you need to make changes or move things or remove things. Which is maybe a little bit better to do sometimes in the staging area. So that's just what I wanted to say, but I think Nikita will go over it as well. But we've been mentioning like the staging area and the repo and stuff. So maybe this will just also help just conceptually understanding what's actually happening in the background. Because remember, when you go to Git, it's almost like a, how can I say, like a public face. So if you go to your GitHub now, because you've created a repository, you'll actually see that repository there. And when I first started learning Git, I think I also had this planets here somewhere. I'm not going to find it now. But I also started doing this, and you will find it here somewhere once you start committing and so on and so on. So these are the repos that I've got, for example. And these repos I can share. Some of them are public. This is a private repo, but some of them are public. So all of my contributors have seen my commits and so on and so on. But it's a very nice, useful tool once you become a little bit more familiar with it. Sorry to interject, Nikita.
Yeah, so that was a big jump forward. We will get there. But just to answer Sunny's question, yes, the GitHub is very important. And like Verena said, it's a middle stage to make sure that you are mindful about the changes you want to commit and that it's not just automatically committing everything to the world. And also, like Verena pointed out, when we create repository, you have the choice to make it public or private. So you also have to be mindful of this. This enables you to collaborate with other people, but we're getting way ahead of ourselves. So first, let's come back to our first commit ever. We needed to do git add for this, then we can commit. And we just demonstrated that having the commit message is actually not optional. So by using the, let's come back to my shell, git commit with the -m flag, it enables us to give a short message. Otherwise, it will open Nano to give you all the space you need to write as much as you like. So the commit message is not optional. You 100% have to write something. However, the more descriptive it will be, the more useful it will be. If your message is, I updated this, or updated or updates, it will be very, very painful to go back and find the changes you were looking for. So this episode here is about tracking changes, and we're trying to train ourselves to make it as helpful as possible. Okay, I hope that answered many questions. If it created more questions, we'll get there in the next couple hours. Is everybody back on track? I still have everybody. Thank you. I have Atli Sane and Yandile Ali. Thank you very much. Okay, so we've done our first commit. We have the git status that always tells us the status of what we've done. Oh, we'll get back to that. You haven't done the test in Nano, so it's fine. The other useful command next to git status is git log, which will show us the edits, the commits, sorry, that we have done. So far we've done a single commit. We have the 40-character unique ID over here. We know the author. We know the email of the author as described in our settings, the date, the time, and the message that we gave to that commit, which was starting notes on Mars as a base. So git status and git log should always be in mind when we were just wondering what's going on, what was done. We always have those two available to us. So next we can keep going. Let's do more commits, more changes to our code. So we will go back to our nano Mars txt, enter. And here I had my little test over here, but that was not relevant to Mars. So coming back to our notes about Mars, I will say that the 2 moons may be a problem for our friend Wolfman. The 2 moons may be a problem for Wolfman. This is my second line in my Mars file. I want to save this. Control O, enter, Control X. I want to check that my line is indeed there. It is. Good. Let's see if Git knows that I did anything. So on our branch, we have changes. That's because I added it. That's fine. Changes not staged for commit. We want to add our mars.txt. Before we do a commit, we check the status. We want to add it to our staging area. You can keep in mind the figure that Verena showed us. Git add mars.txt, enter. I want to check what is my status. He knows I have this Mars file staged, ready to commit. And now that we have already a version saved in our .git repo, there is a version that we committed earlier. And I have a version on my working directory where I did the edits already. I want to know what is the difference between these two. We then have the git command, git diff with 2 Fs to see the difference between the two. So git diff, enter. There's no difference because I changed. What did I do? It's because of the test that I did. Let's see how we can recover from this. Do you see a difference in git diff? Maybe you can tell me what it should say. Does anybody get a message?
I'm not seeing anything. It's just like, oh, okay.
Nothing.
Nothing here. Is it not because we have already added?
No. No. It should give us the difference.
Does it maybe need an argument like which text file do you care about?
No, git diff should be the difference between the last commit and the staging area. Staging area, that's what I did, right? No,
maybe we should commit and try add another line.
Yes, let's do that. Good idea. Okay, let's do it in a minute. So let's go back in our nano.txt and see what is the third thought that we have. Okay. Here, remember we have our third character, mummy, and mummy will appreciate the lack of humidity. So we're going to say, but the mummy will appreciate the lack of humidity. Humidity. So this is our third line. I'm going to save this, Control O, enter, Control X. I'm going to cat my mars.txt, and we have our tree line. That is fine. Now, if we do git diff over here, we should have something. Okay, so that is the difference between our staging area and our long-term storage. I don't think that's true. So this is the difference between the version in our staging area and our local version. Okay, let's see what he says. So diff in Git, it gives us the names of the files. So they have the same names, but yeah, he says an A and a B in front. We have, oops. I didn't mean to scroll. We then have a bunch of numbers. So the second line tells us which versions of the file with the unique IDs. We have those numbers. Then we have, again, the name of the files that Git is comparing. We have the lines that are common in both files. And finally, the difference between them. So there is a plus sign. It tells us that we inserted this third line over here. So before we commit, we can use git diff to make sure we understand the changes between the different versions that we have. So we have this, we haven't added it yet. So we will do that. Git add mars.txt. Still. Enter. I will always check my git status. It is free to check if I'm doing what I think I'm doing. That is right. Once we have added, let's just check what he says now. If we says git diff, he says no difference.
So it must be the add, right?
So once we add, it tells us the difference. There's no difference between the staging area and the working directory because we just added it there. But it is added now, so we can go ahead with our commits. Again, git commit with 2 M's plus a third M in the flag. So we can just give it a short message where we add concerns about the effects of Mars's moons on Wolfman. Git commit -M or flag M, and I will try to not make any typos in my message. Effects of Mars's moon on Wolfman, and then I'm going to enter. I have a new unique ID for my second commit. It saved the message that I asked, and it tells me one file was changed and we added 2 lines. If we were to delete one line, it would tell us with a minus sign what we have deleted. So he's very specific about the changes that we did. Was everybody able to make their second commit? Yes, we have a few thumbs up. Perfect, thank you. What else? So we have done our second commit. That is fine. So we already saw the figure for the staging area, so we can remember this. We want, oh, I see. I'm trying to see what we can do before the break. Let me just show you all the different tools that there can be. So we have a very short, a short project so far. So there's no need to see all the, what am I trying to say? There's a lot of features that we can do. For example, the log size. If you work on a project for very long, when you go to do git log, it can fill up your whole screen. So it is possible to only look at the latest commit that you've done, or the first one. You can only show one line per edit instead of seeing the several lines. This is an option, and we've done your second commit, but we haven't checked the log. So let's go back to the shell to see we've done, let's check our git status. Everything was committed. There's no more edits that were not tracked. And I want to see all the commits that I've done. So I'll go back to my git log. And now we see the 2 commits that we've done. We saw the first one where we started the notes on Mars. And the one we've just done now is to add the concern about the effects of Mars on Wolfram. So if you do git log, you can always get the unique IDs for all your edits, and you can see everything you've done. The limiting the log tip that I showed you on the website is if it gets too long, then instead of scrolling through everything, you can focus on what you're actually interested in. Let's try one of that right now, even if we only have two commits. We will try just one line per commit. So that is git log --1 line, enter, and it will give me the shortened 7 characters unique IDs for each of the commits, and it will give me only the message that I put in. So here it highlights the importance again of having a descriptive message. If your message was, I updated this file, here it would give you a list of unique characters followed by a not helpful message. And you would have to manually go through all the versions to find the special line of text that maybe you lost along the line. So I'm hoping that this convinces you to take the effort to put in a useful message, even if it's just a few words, something descriptive like I edited the dates, or we know you didn't edit, so you can say I changed the dates for the workshop, for example. Does that make sense? Let me check. Yes, I have a thumbs up, so people are still awake. After that, what can we do? Before we take a break in a few minutes, let's just do a quick exercise together. If I come back to the website, we have a few multiple choices question. So now that we've discussed the importance of the commit message, here it's just another figure. We have different edits to different files. So we'll get there. We'll have several files. We do several edits in different files, and we can add both those files to the staging area to be committed together. Or we can do one file at a time. But usually, this highlights the advantage of working in different files. So the version control does keep track of the edits automatically. So there is no inconvenience for us to work in different files. Instead of having one giant Word file where we would have a page on Mars, a page on Venus, a page for moons, we can work in different files so that we can personalize the different edits. If we put everything in one file and we want to go back in history, we would need to make sure we're not deleting important things about Mars when we restore a version about Venus, for example. We'll get back to that after the break, but just as a little teaser, know that the staging area is useful to join files like this. Again, this should be clear in your head, the staging area, and then we use git commit to go to the repository where it keeps all the versions of all the files. Okay, now we have a quick question here for choosing a commit message. Which of the following commit messages would be the most appropriate for the last commit that we've done to our Mars. You can tell me 1, 2, or 3 you think is the best, the clearest, the most specific, and the most straight to the point. We have 1 vote for 2. Anybody else has an opinion? Which would be the best commit message? 2 or 3? Not 1. Okay, let's start there. We can all agree that it is not 1. If we write changes, that does not tell us anything. We know you've committed, therefore we know you've done some changes. Line 2, we say that we added this line to the file. So this is very specific. However, if you do git diff, he would tell you that already. So it would not, you don't gain any information by saying what you added in the line, because git diff gives you the exact change for free by showing you the line with a plus in front for an insertion or a minus if you remove a line. So we believe that 3 should be the best one. It is short, descriptive, and imperative. It tells you exactly what you've done. You discuss the effects, and by doing git diff, you can see the change that you got into. Does that make sense? Can we agree that 3 is better? So we know, we know about git diff, so we should use it. And this will be helpful when you want to go back in history to track your changes. Okay, let's do this short question as well. Which command below would save the changes that we've done? We have 4 different options here. We want to save the changes to our Git repo. What commands do we need to make that happen? Is it, oh, we have a couple votes for 3. So why not 1? What is missing in the option 1? We do git commit. Why wouldn't that be enough? Thank you very much. In order for anything to be committed, we first need a staging area. We need to do that with git add, and the only of those options with git add is number 3. So you were all right. I'm very happy that this is already on your mind, how important the git add is. I can't tell you the number of times that GitHub reminded me, hey, you forgot something. So I like the figure of the staging area a lot. It reminds me that it exists and that it is not negotiable if you want to commit anything. We're going to work with multiple files after the break. So I think we can just stay on time. It is 10. Let's take a 15-minute break, and we will come back at 10:15 to start playing with our history of our files. So let me try the cuckoo timer that that Verena was using yesterday. And let me pause the recording. I'll see you in 15 minutes. Thank you, guys. Like I said, we know how to create a repository, commit changes, how to track those changes. And now we want to explore the history. So this is what Git is for. This is where the version control is happening. We can have a look at all those versions and we can decide to revert back to some changes that we've done. So for that, we need to learn how to explore the history of our changes. So first, let's create a new change. Again, in our Mars file, nano Mars txt. We have our comments about the color, about the moons, about the humidity. And let's say we are doing an ill-considered change. So literally, let's call it an ill-considered change. And we will work with this new change. First, I'm going to save this. As usual, Control O, Enter, Control X to exit. Always good practice to check that we've done those command properly. So we now have 4 lines in the Mars.txt. And let's see the changes that we've done. So without adding, let's do our git diff. And we will look at what we call the head, Mars txt. So adding the head here refers to the most recent comment that we've done. So we can call it the head, and we just do enter on this. So the difference between our latest commit, which was head, and the current file that we have, Mars txt, we see all the same codes and repetition of the name of the file, and we have the changes in the file. So they have the 3 first lines in common. The only change is an addition, a plus sign, and ill-considered change. So that is the difference between the latest commit and the current file on our machine. If we, the reason we're using head over here is that it gives us a point in our history to go back from. So head is the latest commit. What we can add, let's type it from scratch. Git diff head is the latest commit. So we can add a tilde 1 to say 1 further than the head. So that would be 2 commits ago, the second last commit, 1 level above the head. For this file again, we're asking specifically for our mars.txt file. And I press enter. The difference between our current file and the second last commit is the addition of those 3 lines over here, the 3 plus signs that we have. So the first commit that we did had in, no, the second last, sorry, had the cold and dry, but everything is my favorite color. The first line was still in common, but we added 3 lines since that commit. We have a raised hand from Yandile.
Hello, are these things we're doing being added to our account? our GitHub account?
Not yet. We're
Or
not
not
there
yet?
yet. Yeah, we're still
Okay.
working on our local machine. So for
Okay.
now, does that answer your question?
Oh yes, that does. Thank you.
Okay, perfect. So this is the next step. We will start working remotely with GitHub. So right now we can have full automated version control on our machine, but this is only on our machine. So if anything happens to our machine, our laptop, our desktop, then we are out of luck. So like we do for most things these days, we like to have a backup on the cloud, and this is what GitHub will give us. But we will do that next. First, we need to learn how to go back in history so we know how to recover our changes if we want to. We have another raised hand from Sani.
I'm also curious about the like if it's saved online or on my computer. Will it always be on your computer, or is it possible to accidentally have it only on the cloud? Because I'm just thinking for load shedding, I would want to be able to rely on my computer. So will it always be safe at home?
You mean on your computer? It will be
Yeah.
safe as it is. So far, we haven't communicated with GitHub at all. So we are solely based on your machine.
Cool.
Yeah, we'll get back to that, but just because you both are curious about this, when we work with GitHub, it will just be another repository. You will still have to commit your changes to GitHub the same way that you commit to your repository on your computer. So it will just be another place that you can save your changes. And when you have this version on GitHub, it enables you to collaborate remotely with other people. So right now we're only working by ourselves on our machine. We can't collaborate with people. We don't have a safe version on the cloud. That will be the next 2 episodes that we do today. Yes, quite Yandile.
I'm sorry for all the questions. I wanted to ask, what if we made a program but on a different IDE or something? Do we have to run the IDE from our what's this thing? Our command line, the thing we're using now, the bash.
The bash, you can also work in the browser on GitHub, if that's what you're asking about. So first, we're working from the shell only on our computer, and then we will graduate to using the browser and collaborating online.
But if
No,
I write
mean,
like
for those really big programs, what do we do?
Yes, what about big programs?
I think he's asking, how do we commit? Like if you've now written in your Python editor and you have a nice big set of Python code, how do you commit that? Like I assume you come into the shell, CD into your folder and add it and commit it?
Yes, yes, definitely. Any kind of file, it doesn't even have to be a text file or a code. You can commit any types of file to your repository. It will keep track of the text changes, yes. But you can see, especially in the browser, it's very easy to upload and display images, for example. But I'm very happy you're all excited about the potential of this. Let's just focus on the shell for a little longer to play with the history, and then we will really unleash the full power of Git. Okay, thank you for your questions. Thank you for your thumbs up. And let's see, we were going back in history. We were exploring our history. we looked at the difference between the latest commits and our current working directory. And we have, we looked at our second last commit by doing head tilde 1. So I want to go further than this. I'm going to get back to my shell. Yes, git diff. I want to look at my head again, tilde. Let's go back 3 commits before, mars.txt. I see, oh, it's Verena talking in the chat. So git diff head tilde 3 mars, enter. And he's not happy with my head tilde 3. Is saying there's a fatal mistake. There is an ambiguous argument because I don't have 3 commits to go back to. There's an unknown revision or path. If we remember from the git log, I can check my git log to see how many commits do I have. I only have 2. So I have my head, which is the latest one, and I have my head tilde 1. So if I ask something like go back 3 commits before the latest, he says that that's very ambiguous. I don't know what you're talking about. So Git is quite helpful like that. He tells you when he doesn't understand. So we will go back to our second class, which is head 1. And instead of doing git diff, we will try the, yes, raised hand from Yandile.
Yes, don't we already have 3 changes?
How many commits do you see when you do git log?
There's only 2, but then didn't we make 3? Oh, we didn't commit the last one.
Exactly.
Oh, okay, no problem.
Yeah, so this is when git add shows up its face again. If we did not do git add, we cannot commit, and we can still do changes on our computer without staging them and without committing them. So if you have a photographic mind, you can remember the staging area, you have your computer, the staging area, and the repository. So as far as the repository knows, he's only aware of the changes that were committed. So personally, right now, it shows I've only done 2 commits. So I want to see the second last commit that I did. I'm going to do head tilde 1, but instead of diff, I want to try a new command, git show. So git show head, capital head tilde 1, oops, 1, mars dot, I forgot my period, mars txt. Enter. And now we see that this is a little bit different than the git diff. Instead of showing us the differences, it's simply showing us the change. Instead of showing us everything that's in common and then the addition, it shows us the change. No playing around. So here in the second last commit, we added the first line. That's what we did. That was the first line. That was the change. Only what we changed. If let's type it, git show head, which is our latest commit, mars txt. It shows us. Did I do git show head? Here it shows us everything anyway. Why is this so confusing? So here it shows us more information. It shows us the full commit, the author, and it runs diff. So here we still see everything. Okay, then. Another way to go back is history. So we need this code over here. So that's perfect. We already have it. We want to see what is the difference between a specific commit that we have the code for and the current version that we have on our machine. So we do git diff again. Instead of saying head, I'm going to use the characters, or okay, so I don't have to scroll. Let's first do git log. It is for free, and it will give us all our characters over here. So I don't want to type those 40 characters. I'm going to copy paste them quickly. So git diff, and I want to, here I'm going to select the full characters, and on Ubuntu, I'm going to do right click, and it's going to copy them. Then on my terminal line, I'm going to do right click again, and he copied this. Are you able to copy paste this as well? So I did right click and right click. I'm curious, it works for you, Yandile? Does it work for everyone? I'm not sure on Windows, what's the Windows or Mac, what's the easiest way to copy? I just got 1 thumbs up. Can anybody else let me know if they were able to copy their unique ID for the first commit?
I have to, when I right click, it opens a little menu and I have to select copy, and same for pasting, but it's worked.
Okay, perfect. Thank you. Are you on Windows, Sunny?
No, I'm running Manjaro, which is a Linux distro.
Okay, that's good.
Deep Linux.
And Yandile says it works on Windows. Perfect. So everybody's on track. Okay, perfect. Very good. So here I'm going to finish my command line git diff, that very long 40 characters identifier that I didn't want to manually copy because that would be too many opportunities for typos. And then we write the name of the file. So it's going to do the difference between this specific commit and the version that we have here. The version that we have on our working machine. So we can see this is the latest change that we've done. This change is on our working machine. We have not added it to the staging area, and it is not committed, but it can show us directly the difference between those two. So here we did the full 40 characters, but we don't need the 40 characters. Remember when we did the short git log with 1 line. Let's do that again quickly so we all agree. Git log --1 line, enter. It gives us the short version of our identifier. So here you see only the 7 first characters of our very long 40 characters unique ID. He will understand what we're talking about. So let's just prove it by example. Git diff, I'm going to copy again here just the 7 first characters. Again, my Mars txt, enter, and we see the exact same change. So he knows he's comparing the exact same version, but we just want to keep in mind that the 40 character unique ID is very useful, but the 7 first will also do the exact same thing. So, all right, we can save changes to the file so we can see what we've changed. And now we want to restore things. So we've realized that what we wrote earlier was better than what we have now. And we want to go back to one of the versions that we save. This is the reason we're tracking everything in the first place. So we will do our git status to see what changes we have done. And it tells us, of course, we have modified our Mars TXT, and we haven't added it to the staging area. We have not committed it. But we don't want to keep this change anymore. The ill considered change, we don't want it. We want to go back to the latest commit before we added this line. Remember the git checkout. This is how we choose the version that we want to go back to. So here, git checkout, we will go back to our head, which is our latest commit for this Mars TXT. So this will remove the change that we've done. It will restore or revert back to the latest commit. Check out head Mars, enter, and he updated one file from this code. I'm going to cat Mars to see what our file looks like now. And we went back to our 3 lines. So our ill-considered change that we've done is now gone. It was never staged, never committed, and we reverted back. We updated the file back to the head, to the latest commit. Did everybody revert back to the 3 lines? I have 1 thumbs up. Can I have another thumbs up? Are there any questions? Where did I lose you people? Thank you, Ali. You're back with us. Can I have a third one? A third thumbs up so we can keep going. Thank you. Okay, I know I have at least 3 people. Okay, we're back to this. We've done this change. Let's, instead of going back to the head, let's go back to another. Let's check out with an older version. So I'm going to scroll back to get my my first unique ID over here. So that's the same ID we've pasted before. I want to git check out this version and for this file. So this is important. We want to specify which file in this commit. Right now, we're only tracking 1 file, but when your project starts growing and you have multiple codes in one repo, or codes or text, we want to specify exactly which file we want to revert to from that commit. So git check out the ID of my first commit, Mars TXT, enter. It did not update. Let's see what that means. Cut Mars. Was that my wrong ID? So it did not update any path because I was already in this version. So instead of scrolling, let me look at my git log again. git log. Oh, it's, yeah, that's what, it's not the, it was not the right number. Check git check out, and I want my first commit over here. 1, 2, 3, 7 characters. I know I have a typo in checkout. Let me git check out the unique ID of my first commit, and for specifically mars.txt. Okay, now it tells me it updated the path. And I always want to check what that means with a cat on my Mars. And it tells me you reverted back to that single first line that you had.
If you were working with multiple files and you didn't specify Mars, you just specified the ID, would it then restore all of the files that were committed at that stage? At that
No,
point?
no,
Oh.
it is a lot more sinister than that.
Oh, okay, okay. Let me not get ahead of myself then.
Yes, that is the next thing we will check. I just want to make sure everybody reverted back to our first line. If everybody checked out, updated the path to the first line, I'm just going to do a git status to see what it means. Did everybody make it here? So we reverted back our working directory to the first commit that we did. Thank you for the thumbs up, perfect. Then I did git status, and it tells me there are changes to this file that are not committed. So in our working directory, we reverted back to previous changes, but we still haven't committed that. We would still need to commit that to our repository to make sure that's the change we want to keep. Before we do that, Yandile, you have a raised hand. Yandile? Are you trying to speak to us? You are welcome to unmute. Or you can ask your question when you're back. Okay, so we see our change is not committed. But we can go back to our head. So we know we can change between the different versions. So you're all working in your working directory, you're moving between the different versions, looking at what changes you would like to keep, and then you could commit that. For now, let's bring back our latest commit so we get back the changes, the lines, sorry, that we committed earlier. So I'll simply do a git checkout head, which is our latest commit, mars.txt. Now it went back to this version, and I want to check that I got back my thoughts about Mars with a cat, and my 3 lines are still there, are back. So right now in my working directory, I still have all the information that I had before, but I removed the ill-considered change that I had not committed. So exploring history, the topic of this episode is to play around like this, being comfortable finding the different commit version that we have. So git log was very useful. We use git checkout to actually revert back, update the version to one of those versions. And now, speaking of git checkouts and the question that we just had by Sane, what happens if we do git checkout? I'm going to use this, my first commit again, and that's it. I'm going to forget to say, when you look in this comment, I want to see this file especially. I'm just saying, go to this comment. And now he tells me a lot of warnings. So he's saying, look, I'm switching to the commit that you asked for, but you are in a detached head state. You can look around, make changes and commit them. You can disregard commits that you make without impacting things. So this is a state where you can have a look around, but he needs more specifications. He needs to know exactly what you're trying to do. So here it's literally called a detached head state, yes, because he doesn't know what you're interested in. You're just floating around with a detached head. In order to get out of this, we want to reattach our head to the main branch. So we will do another git checkout and we will reattach our head to the main one. Enter. And then he tells you that was the last place your head was. And we reattached it to the branch that is called main. So like Verena was saying in the last couple of days, you can have a look around in the shell. You can play around and you will get warnings, except when you remove stuff. Deleting stuff is the only thing you should think about. But Git here is very kind and he gives you a lot of tips and hints about what you're trying to do. If you mean to do a Git checkout and you don't specify which file you're interested in, he will give you quite some information about it. So I hope that answers your question, Sane. He will not, he protects you. He will not go restore everything without warning you. He will really let you know this is not a state you want to be in. You want to have your head attached somewhere, and I need more specificity about what changes you want to revert to. So we did our git checkout main. We are back to our main. Everything is in order. Here I have a nice picture. So we will go back to the web page. Okay. Sorry. Here we have a figure of our .git repository where all our versions are saved. We have the latest one, which is our head, which includes all the files, has a unique 7-character identifier. Head _1 is one level deeper. So the second last commit, we have different files, different edits, different identifier, and it goes on and on for all the different edits that we have. In order to extract any of the files from our .git repository, we use checkout. For example, if we want the files from the second last commit, like we were doing, head _1, we need to use head _1 or the unique identifier. Either work exactly the same like we have seen. So hopefully this figure is a little bit helpful. And now to put everything together, everything we've seen about Git so far. Let me bring it to the center. We have our Git person over here, which is our version control. We are working on our computer where we have our staging area. We use git add to add all the files that we want to save into our repository. So once we do git add, the next step is git commit. Everything that is in our staging area, to be precise, goes into the main branch, into our hidden.git repository, where we have our head and all the different commits, all the different files are there. To get a file out of our Git repository, we use git checkout. Git add, git commit, git checkout are the three commands we need to work around in our version control. Besides those, we always have at our disposal for free git status, which tells us what we've been doing, what's going on, what should be done, what might be done if you want to stage and commit changes. To look back, we have git log that shows us the list of all the commits we've done. So far we have 5 very interesting comments. Yes, now let's see what other information might be useful. Git status, remember, gives us all the information we need, and it includes a lot of hints. So to read this information that it gives you is often useful. It's tempting to just gloss over it and move on, but sometimes, especially if you're stuck, take a second. He might actually give you what the information you're interested in. Here, let's have a quick poll again on which command would be the best to help Jennifer recover older versions of a file. So she was working on a Python script and it was working great for weeks. And then this morning, it just didn't work anymore. She wants to go back in her version, in her older versions that were tracked with Git to recover her latest commit version. Her code is called datacruncher.py. That was the latest version that was committed. So which of the commands here would enable us to recover that version for her? I am looking at the chat and taking your votes. Option 1, 2, 3, 4, or 5. We have 1 vote for option 5. Anybody disagrees with option 5? All the options here start with git checkout. That's good. We all agree that to revert back to a version, we need to check out the version we're interested in. So here, the change the rest of the comment depends on the version that we're interested in. Here, we're asking about the last committed version of the script, which would be head. So we have a few options here. What's wrong with number 1? Git checkout head. Why wouldn't that work?
We need to specify the file,
Thank you.
right?
Exactly. If we just say version or head, we are in a detached head. So we don't want that. We don't want 1. Option 2, we give it the exact file name. So that could work. The difference between 2 and 3 is the -1. So that is very important because -1 means 1 commit before the head. So that's not the version she wants. She just wants head. So 3 is out as well. And 4, we say git checkout, we give it the name of the file, but instead of head, we give it the unique ID of the last commit. So that is perfectly fine. So our answer would be 5. Either we do git checkout with head or git checkout with the unique ID of the last commit, followed always by the name of the file we want to do. Does that make sense to everybody? Do we all agree on option 2, 4, or 5? Thank you. Thank you for the thumbs up. Very good. You're still awake. Another quick exercise here. Yeah. Here, Jennifer is ahead of us. She's already collaborating with colleague on her script, and she realizes that her last commit contained an error, so she wants to fix the error. So below are the steps, the right steps and explanation that Jennifer can use git revert, but we're missing the first command. So first, here we haven't talked about git revert. It is a little bit different of git checkout commit ID. The difference is that git checkout returns the file not yet committed within the local repository, while revert will reverse changes that are committed. So checkout and revert do the same thing, but to files that were not committed and committed. So here we have all the comments. We just have 1 missing. So here, the explanation in the comment here, we want to look at the git history of the project to find the commit ID. How can we look at the git history? Which is the missing comment here? Thank you very much. Git log enables us to get all the commit IDs for all the different commits. So we don't even have to scroll back. It is free. It is very safe. You can always use git log. Once you have that, you can then copy the ID or the first character of the long ID. And just like git checkout, you can revert. You can see revert here doesn't need the file because the changes are already committed. Type in the new commit message, save, and close. So that was a long story to get you to realize the importance of git log again. Git status, git log, always lifesavers. Here it's another quick another quick multiple choice. So let's do this one. Here is the output of one command. We did cd in planets. We echo Venus is beautiful and full of love into Venus. Git add, echo, git commit, git checkout, and cat. The question is, what is the output of doing all those commands? I will give you a few minutes if you want to try it, or you can tell me what you think will come out of this. So this is putting a little bit of knowledge that we have seen with Verena in the last couple of days. We're using echo, we're using greater than signs, and we're putting on top of that our git commands.
I'm noticing that, so you put the text in and then it's added, but then when the next text is put into the text file, it's not added again.
Very,
Right?
very good
Does it need to be
observation.
added again? And then I'm not sure what happens after that, honestly.
So yes, you've already identified what is the trick question here. So git add was used once after one edit. So we created a file and we added this line here with the greater than. Then we did that again with a double greater sign. What does that do? What is the meaning of double greater than sign?
So we know that appends, right? It doesn't overwrite the file, it adds it to the end.
Exactly. So if we do those two lines, one after the other, we will not overwrite the first one. We will have both lines. Now we're adding the git layers in there. So we did add, we did a commit, and we want to know what does the latest version look like when we check out. So what was the latest commit? What is the line that will come out?
It only commits what was added, right? Like what
Absolutely.
was staged.
Yes.
Okay. So that the suitable, too hot to be suitable as a base will not remain in there when we check it out.
Exactly.
No, that's my thinking. So I guess it's number 2.
Number 2, we would only keep the first line. Is that your final answer?
Oh, I mean, the error is also tempting. I don't know.
So option 4 says error because you have changed Venus without committing the changes. So that's not an error we've seen so far. It warns us if we don't stage anything, but I'm not sure how we could get this error. So
I'm testing out the commands now. I'm just going to write them all down and see what happens.
Yes, you can try. Is there anybody to support Sane in our thought process? I think, did I see a thumbs up? Or was it a raised hand? So Verena is having issues with load shedding at the moment. So I'm sorry, I apologize if I missed a thumbs up or a raised hand.
Okay, so I mean, I've done it now, and it confirms that it's number 2 that it gives us.
You confirm number 2 and you tried it, so it has to be number 2. Okay.
And it's the checkout that's key, right? Because the checkout replaces our current text file with what we
Yes.
committed. If we
Exactly.
didn't check it out and we catted Venus, we would see what we had appended, but then we're like, let's go back.
Exactly.
Right? Okay. Nice.
Yeah, perfect. You worked through it very nicely. Does it make sense for everybody? Are there any questions here? So we're starting to put things together. So it's totally fine to be a little confused. The only trick here is when we did git had. So this is the purpose of the question. If we did echo create a file, include this, and then append this line, and then added this file, both lines would have been included in our commit. But we added before adding the second line. So this line never made it to the staging area. Therefore, it was never committed. Therefore, when we do head to go back to the latest commits, he never heard of this line. He has no idea that you ever worked with it. So if you go back to the last commit, the only line he knows about is the first one. Venus is beautiful and full of love. If we did both lines and then add and then commit, it would have looked like option 3, because we would have staged and committed both lines. Okay, let me check. Can I have thumbs up on this exercise? One thumbs up. Oh, for the people I'm not getting thumbs up from, are you trying it? Are you busy trying the commands yourself? Or can I help with anything? Okay, thank you. I have another thumbs up. Oh, here I left this selected. Just to be clear, in this order, the answer is 2. It all depends on when we put something in the staging area. Okay, so it is 11:10, and I wanted to break at 11:15. So let's have a 20-minute break. Next, we will start doing the fun stuff. So now you know what Git can do. You know how to track your changes. You know how to revert your changes, to go back to collect the changes that you've saved previously. Like we were getting ahead of ourselves earlier, so far it's only on your own computer. Your changes in your .git repository does not communicate with GitHub. We haven't set this up yet. It's not available in the browser yet. This is what we will do next. So by the end of today, you will be able to communicate if you want. You still have to, it's not automatic. What I'm trying to say, everything is safe from load shedding. You still have to manually say that the changes that are on your computer, you want to send them to GitHub, or vice versa. If you work in the browser on GitHub, you can push the changes into your computer. This is what we'll do. So at 11:30, we will meet again. We will set up your computers to be able to communicate with GitHub. And at this point, you'll be able to collaborate. Once we are set up with GitHub, you can collaborate between each other, between different projects that are all available on GitHub. And that will be it for today. So that is my goal. by the end of today, I want you to be all set up to do whatever you like with any collaborator that you like. So let me start this for 11:30. So this is 18 minutes. Let's see how I can do that, but let me pause the recording. I'll see you at 11:30. Thank you, guys. Thank you for your work. A quick thing that I meant to point out to before the break is ignoring things. Verena quickly also mentioned it earlier today. If you have several files, and you will have several files when you work in your real work, your real projects, you will create a bunch of files. And maybe you don't want to keep track of all of them. You don't have to. You can tell GitHub to ignore specific files. So I want to get to the GitHub part, so we will skip this right now, but you can go in the git ignore file and list everything that you want to ignore. So if there are specific files you don't want to track, for example, data files that you are not actively editing, if you have directories that you want Git to ignore, that is a thing you can do. But right now we're working with just one file, so you can come back to that when you need to ignore some files. Now we will start working with remote repositories in Git and GitHub. So we've checked earlier, everybody created a GitHub account, and we are now going to use it. So we have learned how to use the shell and the terminal to do everything we need to do on our laptop. And we now have the internet and browsers. So we can do everything we've done directly in the browser. So the first step that we've done today was to create a repository in our own machine using the terminal. Now we will do that using GitHub. So in my browser, this is my GitHub page with my username, repositories that I actively work on. And I'm going to go here at the top right to click on the plus sign and new repository. So maybe you can watch me quickly, and then I will give you a couple minutes to do the same, just so that we know what we're doing. So at the top here, there's a plus. I click new repository. This brings me to the new repository page. I am the owner, so the repository is going to be on my GitHub account, and the repository name, we will make it the same as the one I created in my Ubuntu. So simply planets. I will keep it public so that anyone can see it and contribute when I add them as contributors, which we will do in a second. And everything else we will leave unchecked. So there is the possibility to add a README file, which is very useful to add comments and the usual README stuff, how to run the code or comments about what we mean to do with this code or text. But for now, right now, just planets, nothing else, and we create the repository. And then it did create this new repository in my GitHub account, and it gives us a link for it. So we will get back to this, but first I would like you to go in your browsers, in your GitHub account, and create a planets repository exactly like I did. So I'll give you a couple minutes to do that, and please come back with thumbs up when you've had it, or tell us in the chat, or speak up if you need some assistance. Okay, thank you. I saw a couple thumbs up already. We have a third thumbs up. Thank you. So I'm missing, oh, another. So I'm just missing 2 thumbs up. Are we getting there? I don't see any complaints in the chat. Should I assume everything is going fine? Excuse me. Okay, let's quickly have a look at figures back on the web page. So what we just did by going to the browser to create a repository on GitHub is exactly what we did at the beginning of today's session, where we created a Planet directory. We went inside it and we did Git init. And that meant Git can now track everything that is in the Planets folder. So this is what we've done in the staging area. The Git, our terminal, in our shell, in our personal laptop, where we had our staging area, our repository. So we still have that. However, now we have a second one on GitHub. So the first one is on your local machine, and we have an empty Git directory in our GitHub over here, which is also called Planets. We called it the exact same thing. So now we want to do is synchronize those two. So I asked you to create an empty Planet directory without a README file, so it would be perfectly empty to receive the contents that we have from our own local machine. So to do that, we're going to copy the link that he gives us over here. So we're going to use SSH, the secure shell host, I think. SSH is what we're going to set up in a moment. So I'm going to copy this link, and then I'm going to go to my shell, where my first Planets repo was created. So here in my directory, let me check. I'm still, oh, let's even clear this with an R, clear. I'm in my Planets directory. And now I want to connect my local repository to my remote repository. So to do this, I copied the link that GitHub gave me. And in my shell, I'm going to say git remote add origin. And I'm going to paste the link. Oops, I lost it. Let me copy it again. Right click. This is the address given by GitHub. So the command to connect my local to my GitHub repository is git remote add origin. Then I click enter and that's it. He doesn't complain about this. This is good news. I'm going to check that he connected them properly with git remote -v. Enter, and he says, yeah, I have an origin where I can fetch from online, and I can push to the online directory as well in my GitHub account and the name planets. You're up next. Are you able to connect your two repositories, sorry? Sane is connected, thank you. Ali is connected as well. Masha as well, thank you. If I can have a couple more thumbs up, we will keep going with the setup of our SSH background. Was everybody able to get the right link to their GitHub repository? Nothing in the chat as well. Maybe that's a good sign. Okay, I will take your silence as a good sign. Perfect, another thumbs up. Let's keep going. So now we will set the SSH, which stands for Secure Shell Protocol. So right now we have linked it to repository, but not anybody is allowed to contribute to it. So we need a way for GitHub to be able to authenticate you when you want to do edits to the work. That is only fair that we should be able to do this in a safe manner. So to do that, we use the SSH. Maybe I should ask, have you heard that before, SSH? A way to connect between different computers?
I know my boyfriend has like taken over my computer when I can't fix something by SSHing in. So I've heard it. I don't know what it means. Feminism.
No, that's very good. SSH is indeed very helpful to help other people. And personally, I like to connect from my own laptop to the work computers. So at any time, if there's something on the lab computers that is having issue, I can quickly connect to it, fix what I need so it keeps doing what it's doing, and I can stay at home. I don't have to run to the lab to fix it. So in general, that's the first time that I personally heard about SSH, and it's the name to safely connect computers, and in our case, to connect to GitHub. So coming back to our shell, we're going to run the list command to check what pairs of SSH keys we already have on our computer. So ls is the list minus al space tilde, which is our home directory. And from there, the SSH keys. Enter. And you can see that in my case, I already have a couple keys here. I have a .public key and I have a private key. So the private key is never to be looked at, but the public key is what GitHub needs to be able to connect to my local repository. So GitHub knows I am me and I'm allowed to contribute to my repository. So in your case, if you've never done this process, you will not have those files, which we will create them for you right now. And once this is set up, you can forget about it. So I want to make sure we get to this point today, so you are free to collaborate in the future. So here, to create a key, we have a very fancy command, ssh-keygen for key generator, space -t ed25519. This is a specific system for specific algorithm. This should work for hopefully all of us. Then we keep going with a -c and our email address. You know what? I don't want to remember the email address from earlier, so I'm going to scratch that and do my git, was it git global list, I think? No, that wasn't it. What was it? Git list, maybe? I forgot. Git list global. Does anybody remember? Let me go back. I'm just being lazy here. Let me go back to the beginning of the session. That's not helpful.
Git config --
Git config, thank you.
Just looked it up.
Perfect, thank you. The git config -- list. There you go. So now I can just copy paste this and get user email. Yes, that can also work. Thank you. So now I'm coming back to my fancy line, SSH keygen -t ed25519 -c. And in between quotes, I'm going to give it my private GitHub account. End quotes. And once I have this, I can press enter. He will ask which file we want to save it to. We just want the generic one, the default one. So I'm going to do enter. He warns me that I already have one. So I'm going to create a new one and say yes. And that is it.
Mine asks for a passphrase. Is that
Yes.
normal?
Yes, it should add. So yeah, mine, I already had one. So he already knows
Okay.
what I think of passphrases. You can give it a passphrase if you can remember it, or you can just press enter to leave it without a passphrase. So to be quicker in the session, I'm leaving it empty. I can have another one next time. Should I have? Let me just do once you've created, you can do -al again to check if you have your keys. So he did not do them. Those are still the one from yesterday. Let me check that again. Enter file, yes. Or overwrite, yes. Okay, here you go. He didn't understand my yes. So enter passphrase. I'm going to leave empty for now. Enter, I still want no passphrase. And then you should get a fancy random art image to tell you that it did create keys or new keys. Then let me check a double check that he did indeed create keys. So ls -al // enter. And now this is the current time. So I have brand new keys. If I can get a thumbs up when you have your keys, we can go back to GitHub. Oh, yes, I have a raised hand. Oswald?
Sorry, I think I got lost in where we were trying to, when the line says enter file in which to save the key, I didn't got lost what you said we're supposed to write there.
You can just do enter and it will use the default.
Okay, thanks.
Good, so you will be there soon. Thank you. I have a second thumbs up. How is everybody else doing? Another thumbs up. Good. Once we have our pair of perfect, Ali also gives thumbs up. Sorry. Now that we have an SSH key pair, we have a public key and a private key, we can run this command to check if GitHub can read our authentication. This command is ssh-t git at github.com. Enter. And it tells me permission denied because I did not give my key to GitHub yet. I've only created the keys. So if you can just check this, because I've run this before, it's only tell me permission denied, but first you have to tell Git that he can read. You can ask your computer for the key. So if you can just run this line, it will give you a bunch of warnings and then tell you that GitHub does not have permission yet. So first we need to copy the public key that we just created and give it to GitHub in the browser, and then we can finally authenticate our work. So first we're going to cat our public key. So that is tilde-sid_ed25519.public. We only ever look at the public key. So when we do cat, it's going to give us the very secret key over here. Don't worry, I will change it after the session. So I need to copy all of this to give it to GitHub in the browser. So I'm going to copy this with my right click, and then I'm going to go back to my browser. Where is my browser? Here? Yes. So once I'm in my browser, I go at the top right where my icon is. I go in settings. So again, maybe just follow along with me and then you can have a minute to do it, just so you know what it looks like. So I went to the top right, went into settings, and here there will be an option for SSH and GPG keys. That sounds promising. And here we can add the SSH keys for all the computers that you want to work on. So at the top, I click new SSH key. And here I'm going to paste what I got from my terminal, from my shell, sorry. So I gave it a title for this. This is my Ubuntu machine. Oops. My Ubuntu, this is a key, and I paste the key there, the whole thing with the email, and I say add SSH key. And then, of course, I set up my 2FA. So while I do this, you can try it as well. Go paste your key to GitHub. Maybe I can show back my terminal so you have the commands to cat your key. There you go. Thank you. I got 1 thumbs up already. How is it going? Is there anything I can help with? Are we getting there? Yes, thank you. Another thumbs up. It's so nice to see your thumbs up. A third thumbs up. Four thumbs up, thank you. Okay, if nobody's asking for help, I think we can try to connect our GitHub to our local machine. So once GitHub has your public key, you can try the command that we did a minute ago, the SSH-T git@github.com. Once you do that, you should get something nice. GitHub saying hello, and you're successfully authenticated.
Mine says the authenticity of host github.com with a bunch of numbers can't be established. This key is not known by any other names. Are you sure you want to continue connecting? Shall I just continue regardless?
Yes, yes.
Okay.
Yes, so after you say that, it should say permanently adding GitHub to the list of known hosts.
Yeah, and now it says, hi, username, you've successfully authenticated.
Woohoo! That is a good thing to read. Once we're successfully authenticated, then we can actually work. So could I ask for a quick thumbs up once you're successfully authenticated? So we can finally, thank you, thank you. Once this is done, we can finally start pushing and pulling. Pushing is literally pushing the commits from our local machine. When we're going from our local machine to the remote machine, we call it push. And when we want to get files from GitHub, the remote host to our local host, we call that pulling. I have a raised hand from Oswald.
Yeah, mine says connect to host github.com port 22 connection timed out.
Timed out.
Yes.
Can you try again?
Yes, I tried multiple times. It still says connection timed out.
Okay, interesting. Is your internet is working fine? Your Zoom is not having any issues, is it?
No, it's not.
Okay, timed out. I'm wondering if your key is entered properly. Let me show here. So when you added your key, that's what it should look like. It should tell you the name and it should not complain. Is that what you got?
Yes, there were no complaints.
There was no complaints. Did you copy the whole line? Did you include your email address?
Yes. Wait, let me check. I think it missed it.
Okay, try again the full line.
Okay.
Yes, if I just go back up, oh no, it's right here. So the full key should start by SSH minus ED 25519. Should be a long line of gibberish, and then your email address.
Okay, let me try and see.
So the whole line should be copied and given to GitHub.
Yeah, I did copy the whole line.
Then can you just try again adding a key and see if that one works? Otherwise, timing out, I usually it means it timed out. The connection took too long.
Yeah, it's probably in the network issues.
Yeah, well, keep trying. Maybe it will come through. Otherwise, you can try later and see if it works better.
Okay, thanks.
Yeah, I'm sorry about that. Timeout is always a weird issue. It's hard to know what's up with it. But thank you for noticing us. And yes, try to keep following. But is anybody else having any kind of issue, or did you get the hi from GitHub ready to go? Quiet. I'm going to assume everything is all right. And now I was talking about pushing and pulling. Right now, our GitHub repository planets is totally empty, so there's nothing to pull from it. But on our local repository, we have our mars.txt file that we've been working with. So we can finally push that to GitHub. So we have a safe copy to the cloud. To do that, we will do a git command called push from the origin to the main branch. And I'm going to do enter. Then it tells me what it's done. It's telling me the number of objects that were there. It was able to count them. That was done. A bunch of gibberish, compressing the objects, writing them. The total that worked, everything was resolved. There was no mistakes. So now everything that was in our local Planet repository was pushed to this repository on GitHub from our local main branch to the remote main branch. Once we do that, let's go quickly check to the browser. It's always nice to see things in a GUI. So I'm going back to my browser and I want to see just my main page. So I just clicked on my user account and now I have the repository called Planets that I created completely empty in the browser. However, it now has my mars.txt file that is coming from my local machine. So here, we had to use a lot of commands in the shell to see a lot of information. For example, the message for the latest commit, it is given to us right here. On the side, it is telling us 2 hours ago, which was the last edit. When we hover over it, it tells us the actual timestamp, the date and the time that it happened, if we don't like to think to calculate how long ago was 2 hours ago. Here we have the latest commits. We have the unique ID that was 2 hours ago. We have the number of commits. If I click on this, what does that look like? What command did we have to do in the shell to get this kind of information? Thank you. This is our Git log again. So in one click, we have a very nice graphical interface showing us all the different commits, our 2 commits we've done 3 hours ago, 2 hours ago. We have the full message. Again, if the message we wrote was just updated file, here we would have a giant list of, oh, update file, update file, update file, and it would become very annoying. But we did a good job. We put in the effort of putting a useful message for the commit, and this is what we see here. And again, on the side here, we can copy the ID of the commit. We can see all the details of the commit, and we can browse the repo at this point in the history. So for example, if I click on view commit details, yes, it brings me here to something familiar. What command did we have to type in the shell to get this type of information? That was a nice command that we used to see the plus signs or the minus signs, showing us what the files have in common and how many additions, how many deletions. Anybody remembers the name of that command in the shell? It was diff indeed, Sane. We had diff, we had git diff, git show would show us the exact same thing, would highlight the differences. I'm bringing you here just to show you a very nice addition that we have in the browser. You can see when I move on the line here, there's a plus sign that shows up. If I click on it, it enables me to add a comment. So when you collaborate in a group and you all do edits and changes, commits on your sides, you can actually go back and comment on each other to give appropriate comments on or feedback on the different edits. So that's what I wanted to show you in the browser. If I go back to my planets, I have, here would be the list of the files. So far, we've only worked with Mars dust text. What else? We did push, now we need to do pull. So I'm going to go back to my shell. In my shell, so the last command we did was git push origin main to push from local to remote. To pull from remote to local, it is the same command with a pull instead of push. Git pull origin, origin main. Enter. And he said, you know what? It's same. It's already up to date. There hasn't been any more commits since you last pull. So currently the version on my local machine and on GitHub are perfectly synchronized, perfectly up to date. We've been through the browser, so that worked. I think that is it for setting up our remotes. Are there any questions? Is everybody up to date like me? You've tried a git push, a git pull, and there was no complaints? One thumbs up. Two thumbs up. Thank you. Another thumbs up. Oops. Okay. Okay, I assume everybody is on track and everything is set up. So from this point, your SSH is set up, your GitHub is set up, your Git is set up, and you can do version control of any work you do on your local machine or on GitHub, and you would be ready to go. For the next half hour, I would like to do some practice. So we can start integrating the GitHub comments that we've seen already and adding information to text files, all the nano stuff that we've done for the last 3 days now. So what am I sharing right now? I'm sharing my terminal. Let's go to the browser. No, that's still not Ubuntu. I want this. Okay. So the last episode for today is all about collaborating. So once everything is set up, we want to clone repositories. So we can clone repositories from someone else, not necessarily push and pull just between our own accounts on GitHub and on our computer, but we can clone a repository from GitHub and we can collaborate to a common repository. So first, in order to collaborate with someone, we need to add them as collaborators. So we can do this in the graphical interface in settings and collaborators. So you can add people like this, and then you will be able to clone each other's repositories. So the first step, I'm going to put that page in the chat so you all know exactly what I'm looking at. This is the page and the instructions to collaborate. So I think the first step, is it the first step? I really want to use the breakout rooms so you can work together for a little bit. So you can use the link I just sent to have those instructions. You go into your settings, no, here, the settings of your repository and collaborators. and then you can add someone. So I will send you to the breakout rooms. You can exchange your usernames to add each other in pairs as collaborators. And then you go and use the git clone command. Here, the git clone command, you will use, well, let me show you just for myself. Let's do that, but it will be boring because I'm the same person. So let me quickly go back to my terminal and then it will be up to you. So the command that I want to do, and then you do that between each other. So you both become collaborators on each other's Planet repository on GitHub, your remote repositories, and then you clone each other's. So for myself, working with myself, I do git clone, git at github.com, and my GitHub accounts. The name of the repository on GitHub is planets.git. And I want to clone this on my local machine. So I do space ~/desktop. Oops, I use the tab here to autocomplete without doing any issue. And since I already have my own Planet directory, and we all have a Planet repository, so we need to give it a different name. Here I'm cloning the repository from Nikita Burn, so I'm going to call it Niki planets.git. So this is very similar to the copy paste that we've used before. The first is what we want to copy or clone in this case, coming from GitHub, and we make a copy, we clone it on our local machine. So here I want to highlight, we want a different name. Very critical because you already have a planet. Oops, unless I do a typo, plantet, okay, planets. The new one that will be cloned is called Niki. So now I will put you in breakout rooms. Please exchange your usernames, add each other as collaborators, and then clone each other's directories. Once you have a copy of the directory, well, let me press enter on this. It's telling me it is cloning it, and that is it. I have a copy. Let me do ls. I'm not in the right directory. I want to go into desktop. Let me go back to planets. Next to planets, I have the Niki planets directory. So this is coming straight from GitHub. And actually, this is a directory. There shouldn't be git at the end here. That was my bad. Let me rename this quickly. Move this to just nothing at the end, Niki planets. So that looks cleaner. So once you have this, you can go into each other's code and push edits to the GitHub repository. Okay, enough talking. Just open the link that I sent in the chat. You have all the instructions there. First, exchange your usernames. And from there, me, Ashar, and maybe Tajudeen, if you like, we can go around the breakout rooms and see how it's going. But the last goal for today is just to be able to clone a directory and push edits back to GitHub. Okay, I hope that makes sense. Assign, we have 1, 2, 3, 4, 5, 6, 7. So I will create 3 rooms. And so you should be in teams of 2 or 3 and just become collaborators, exchange your username and play around and let us know when you want assistance. Okay, let's try this. If anybody is not getting the invitation to go to a room, let me know. Otherwise, okay, people are moving. Good, good, good. Mushrooms.